All right, homework, I think it's 7.5 backside. What have I got underlined on the backside? I got 18. Let f of x be negative 2x squared and g of x be 2x minus 4. On the set of axes below, draw the graphs. I would fully expect this to be a non-calculator problem. Draw them. I would expect it to be non-calculator. 2x minus 4, fall 4, rise 2, run 1. Now, because this is a problem, I say it's non-calculator, you're still going to have a technology assist, so you're not going to have to plot many points. When you do it by hand, you got to draw lots of points because usually, for one, those points tend to be intersections, and two, you want things as straight or as curved as they need to be. Now, negative 2x squared would be like mom, except it would initially fall 2 and run 1. Remember, mom is x squared, mom is this. You're supposed to know those points, okay? Now, after that, you have to kind of think, if I plug in a negative 2, you might have to make a little table. If I plug in a negative 2, maybe I have to do it by hand. I don't know. I get back a negative 8. So negative 2, drop 8. There's that. And what's cool is over here, you already have the other intersection. Now, I say this is on a non-calculator part. Even on your EOC, you'll only have to pick like maybe 2 points and it'll draw the rest. But you have an answer here and you have an answer here. One of your answers is negative 2, and the other one is when x is 1. I hope you can look at the grid and see that. They only want the x values. And then the ACT, because I would like to see you guys make a really good high ACT score. That would be some justification of how hard I've worked my butt off this year for you. A bag contains only quarters, dimes, and nickels. The probability of randomly selecting a quarter is 1 in 6. The probability of randomly selecting a nickel is 1 in 4. Which of the following could be the total number of coins in a bag? What we call a probability space. I think that's what they call it. It's been a long time since I taught stats. But I'll just mansplain this to you. Probabilities add to 1. So 1/6 plus 1/4 plus this missing probability, this was quarters and nickels, so plus the probability of what, a dime, has to be 1. I don't feel like working this out without a calculator. I probably should, but whatever. Should be 14/24, which would be what, 7/12? 1 minus 1 over 6 minus 1 over 4, 7/12. Probability of a dime is 7 in 12. Now, anyways, this helps me answer possibilities. If the probability of selecting as a quarter is 1 in 6, that means there might be 6 quarters. There might be 4 nickels. There might be 6 quarters. There might be 4 nickels. And now I know there might be 12 dimes. Anyways, if I just put those numbers together, I should get 22, which wasn't up there. Bummer, it wasn't there. Oh, bummer, that stinks. So I got to find something else that actually works and follows this model. What I want is I want things that it's easy to do of. Can you take a sixth of 15? Can't take 1/6 of 15. It's a decimal, right? Do 1/6 of 15. Sorry, 15 times 1 over 6. It's 2.5. Doesn't make sense. I could take a 6 of 24. 1 over 6 times 24. That's 4. That works. It's a possibility. I can also take a 6th of 30. That's holding. Can I take a 6th of 32? This is probably how I should approach this problem from the get-go. Can't do it. And can I take a 6th of 40? I didn't think it'd be this easy, to be honest with you. No. I narrowed it down to two choices. So what can I take a fourth of? I can't take a fourth of 30 and get a whole number. There we go. That's how I should approach this problem from the get-go. So this was nice to know, but it's not how you had to answer the question. I forget now that I'm older, little things like that I should have done. In the xy coordinate system, if the point RS and r plus 2, s plus t are 2 points on a line defined by the equation y equals 4x plus 5, then t is what? Well, that's interesting. So I know 2 points on a line. I wonder if there's an easier way to do this other than pure substitution. Yeah, there is. Boy, that's hard to explain. What happened here is the r value increased by 2. Notice this. X value increased by 2. So if the x value increases by 2, I plug that in, the y value increases by 8. Boy, if I was your age, I'd have a tough time with what happened there. I really would. It makes perfect sense to me now, but I'm old. What I decided is I noticed that x increased by 2. So if I throw that 2 in, I would have to add 8 units. That's how it is. 52, let the function g be defined by g of x as 3 times x squared minus 2 when g of x is 69. What is a possible value of 2x minus 3? Well, I'm going to set 69 equal to this thing. And they kind of cheated your way out of this one where you can't just plug in numbers to some degree. I'm going to divide by 3, get a 23. I'm going to one-side it. I'm going to actually add 2. 25 is x squared. And the x value is either plus or minus 5. It's one of the two. Could be both. It says, what is a possible value of twice x minus 3? So I'm going to do 2 times 5 minus a 3. I'm also going to do 2 times negative 5 minus 3, just to make sure. Twice a 5 minus a 3 would be 7. Twice a negative 5 minus 3 is negative 13. And the only one that shows up is the 7. 53. If a plus b is 25 and a is greater than 4, which of the following must be true? So I'm just going to isolate A. A is, actually I don't know if I want to isolate A. I'm going to isolate B. B is 25 minus A. That's what B is. Now they said A is greater than 4. Boy, that really throws you off. So I don't know how you actually show this out with algebra. But if I'm bigger than 4, I could be like 4.01. So then B would be 25 minus 4.01, which is 20.99. And I could be anything else. The one thing I could not be, again, I can keep doing this, I could be 5. So I could do b is 25 minus 5, which means b is 20. If I'm going to be bigger than 4, I can never actually exceed 21. I can't actually equal it. There's the statement. I hope you can reason your way through how that's working. Just made up a number and it's done. Happy ACT.